Welcome to the Mars Federal Colony. For your safety and comfort, domes have been installed to protect you from the vacuum outside. Please do not touch exterior windows or airlocks. And remember, it took a team of rocket scientists to deploy Linux on this planet. Thank you and enjoy your stay on Mars. Which means this week we talk with Brandon Edwards about targeting, exploiting, and defending Linux, whether it's in IoT, container, or cloud. And in the news segment, supply chain remains supply pain. Web shell remains post-exploit hell. System availability remains key sustainability, and more. Get ready for a surprise, and stay tuned for Application Security Weekly.
This is a Security Weekly production. It's the show to learn the latest tools, techniques, and processes necessary to understand DevOps, application security, and cloud security. Your trusted source for the latest application security news. It's time for Application Security Weekly. Cloud native development presents new challenges for security teams. Ephemeral workloads are scattered across services, and it's hard to identify resources, monitor configurations, and ensure compliance. Prisma Cloud by Palo Alto Networks is a comprehensive cloud-native security platform, delivering full-stack protection for multi- and hybrid cloud environments. It provides deep visibility, threat detection, and data security, as well as protection for hosts, containers, and serverless while enforcing policy guardrails. Visit securityweekly.com/Prisma Cloud to gain control over your cloud security. Application security is hard when security is separated from your DevOps workflow. Security has traditionally been the final hurdle in the development lifecycle. Iterative development workflows can make security a release bottleneck. With GitLab, security is built into the CI/CD process. Every code commit is automatically scanned for security vulnerabilities in your code and its dependencies. Results are delivered to the developer in their native workflow for rapid remediation. Learn how GitLab enables DevSecOps. Visit securityweekly.com/GitLab for a 30-day free trial.
This is episode 140, recorded February 22nd, 2021. I'm your host, Mike Shima, and I'm here with John Kinsella. Hello, John.
Happy Monday. Mike, how are you?
I'm doing well. Happy Monday. Glad to have you here. Also curious, John, if you'd like to stay in the loop on all things Security Weekly. All things, not just Application Security Weekly. Visit securityweekly.com/subscribe to subscribe on your favorite podcast catcher or our YouTube channel. Sign up for our mailing list and join our Discord server. You could be chatting with us right now. If you missed any of our previously recorded webcasts or technical trainings, they're available for your viewing pleasure at securityweekly.com/on-demand. Brandon is the co-founder and chief scientist at Capsulate. He is responsible for cybersecurity research strategy and for operationalizing findings into resulting innovations. Prior to Capsulate, Brandon was VP of Threat Labs at BAE Systems, having joined the company through its successful acquisition of Silver Sky, where he designed their cloud-based zero-day prevention product. He has also served as hacker in residence at the NYU Tandon School of Engineering and held senior security roles at Tipping Point and McAfee. Hello, Brandon. Thank you for joining us.
Thank you for having me. I'm really excited to be here today.
It's great to have you here. And you're targeting, exploiting, and defending. It's almost like we have our TED Talk of our own about all things Linux, it seems. I'm curious, we've got a focus here on Linux. And maybe when we start to talk about targeting it or finding it, where are some of the surprising places that it's shown up for you in the past?
Well, Mars, as of recently, but I think really just the fact that it eaten the enterprise infrastructure without people noticing it, right, is the biggest surprise. Like, while you may find it in your fridge or in your smart internet-enabled health tracking device or whatever the case may be, the bigger surprise, I think, is when you talk to people and say, well, how much Linux do you run, or do you run Linux? And they say, well, no, we're a Windows shop, or we're all of our devs are on Mac. And you're like, oh, okay, cool. So your infrastructure, then they're like, yeah, it's all in AWS. And then that ding, the light goes on that actually they are a Linux shop. I think, or whatever, Cloud, GCP, Azure, even running on Microsoft, they're actually running Linux instances. And so when that goes off in their head, I think that's really the biggest surprise, because Linux somehow went from being this sort of garage hobbyist operating system that your really eccentric friend into super indie music was into tuning for their own personal firewall to, like, all of a sudden everywhere, right? And I was that weirdo with tuning my Linux box in the garage. So I'm happy to see it here, but I think it is still a surprise to many.
Yes, well, definitely welcome to fellow weirdos. And I think you're right, pointing out just there's the cloud, which is sort of the obvious, or maybe not obvious because it's perhaps so abstracted, but plenty of places within the enterprise. And sort of that leans us into the idea of you have an attack surface in the sense of Linux in many places, whether they're surprising or mundane, but also just the attack surface of Linux itself. We talked 2 weeks ago about the recent Sudo vuln. So what
Yeah.
does it kind of look like when, targeting Linux? Is it pretty easy to find these types of Sudo vulns, or what do people go after?
I personally am still shocked that there are more Sudo bugs to be found. It seems to be the gift that keeps on giving. It's obviously a really hard thing to get right. It actually makes me wonder. I do want to get back to like targeting and talking about other attack surface elements of Linux, but Sudo itself, I think Spender tweeted about this, that we had this idea of separating root account from having a password, because passwords were such a problem and still are in many ways. But instead, we've now introduced things like Sudo to leak privileges down to users through userland. And it makes one wonder, like, is that the right way? Should we now just would we be better positioned now if we go to having root accounts with strong key auth only, or some secondary factor? I don't know, but I can't speak to the complexity of finding Sudo vulns in the modern era. I think they're obviously there to be found, but I do think the ecosystem itself is rich with things to target. Right, it's not just set you binaries like Sudo anymore. You can now grant programs capabilities, capsys admin, other capabilities. And it's interesting actually watching how people think about this, because not everyone is really caught up with the threat of that, I think, because if you look at, for example, LS, out of the box on many distros, you run it and you're going to see set you binary lit up in bright red in your terminal to indicate that this is a potentially dangerous program that needs to be treated sensitively. It has privileges on your system. That sort of highlighting doesn't necessarily happen with like capability granted programs. So I'm not quite sure that people are really thinking about it in the same way they should. That being said, there are also other considerations, right? Is a Sudo vulnerability as interesting in a container versus a kernel vulnerability, or something that actually has other capabilities granted to it, where the capability limitation in the container might be more concerning than, say, the set UID limitation or the user limitation, right? Which is why a lot of people don't even run user namespaces for that matter. But yeah, I think the ecosystem is really rich for targeting right now. I think there's just such a diverse set of ways that people are thinking about attacking Linux, and you have so many different elements to consider, from the distro's individual security, the package level security, the supply chain. What are the dependency chains for those packages, and how are you keeping them up to date, between everything from like Snap being a modern thing to the traditional package managers to the third-party supply repos. It's a really interesting set of problems for targeting, and I think it gives attackers lots of opportunity for targeting to then move on to exploitation.
Yeah, and I guess a little bit of what you're kind of getting at too near the end there is that, in fact, there's quite a bit of kernel fuzzing, lots of interesting vulns being found that way. But when there's so much patching out there, if you can just target a system because it's behind on a patch or two, or maybe even a behind on a month or two worth of patches, that's kind of the easy way in. So it's more of perhaps this aspect that there's this long history of C-based software, and patching might be available or might not be available, but you have to apply those patches just to start off with.
Yeah, and that raises an interesting point, I think, around the kernel fuzzing in particular. You see the syscaller, sysbot running publicly on display, posting these bugs that it's finding for everyone to see. Some of them are treated as vulnerabilities and fixed as such. Some are fixed and not treated as vulnerabilities, and some are not handled at all. They just roll on and continue to exist as bugs that can probably be exploited. It's interesting because there's, based on the willingness to categorize them or classify them as vulnerabilities, and how much effort's put towards that, influences the distros, which, even if they are vulnerabilities, may not choose to adopt them or adopt those fixes at a early or fast rate of any sort. So you've got this weird cascading set of like uncertainty around vulnerability from, are the bugs security bugs? Maybe, probably. Should they be treated as that? I don't know. Are the distros going to care about these fixes? Maybe, I don't know. Am I currently patched for, at any given time? How certain are you of your kernel's security posture, given that there is so much uncertainty and known issues that are still present and being publicly displayed. And all of this is from a public project that I think is meant to kind of show this the greater ecosystem of how we're not really in sync with security in this way. And that's speaks nothing to people that are running privately and trying to achieve the same output of bugs, but maybe for other nefarious use. So it's definitely an interesting time in the Linux world for security.
Yeah, definitely. And so let's switch a little bit from that targeting aspect, just saying we have perhaps a rich opportunity for finding vulns, but into that exploiting aspect a bit. And I want to start off with, you sort of hinted at a way, does root matter in a container? Does it, do we actually need to get root anymore, or does getting root and having that privilege escalation, is that always really necessary in modern exploitation?
That's a really good question. I think it's really environmentally specific, and the diversity of the way when you talk about containers, for example, the diversity that you see in the orchestrators, the runtimes, container engines, deployment models. Is it a, Damon said, is it sidecar loaded? Are you how many things are sharing this namespace with you? So there are varying levels of like, well, what does root mean there? But I even question that with most container deployments, for example, if you deploy it as a single user, root or not, does it matter if you get root in that container? I don't know. I mean, unless you're trying to break out of the container, it seems too often that just getting into the container, there's no level of privilege separation. So it doesn't matter if you're running as www data, if that's all you need to access the resources or the keys or whatever your target is of that you're trying to get out of that attack. It is really interesting though to me, like, containers have some sense of isolation and segmentation with capabilities depending on how it's deployed. So what you might see as a developer running the container in Docker on your machine and then checking to see if certain permissions are available or not, and maybe giving yourself a sense of comfort, does not necessarily reflect what's going to happen when that container is pushed out through Kubernetes, which I think they had a PR for doing some amount of seccomp. I actually don't know what the current level is, but for years had no seccomp policy applied, which is sort of one of the primary pillars of security for containers. So how do you even make an assessment of what is root and what sort of segmentation is there? It's a complicated problem. And again, people aren't even using user namespaces yet. And partially because I think the complexity involved in doing so often means that there are constraints such that you either have to rewire your application or your deployment model and risk opening up yet more attack surface or fumbling other things. So I don't know if root really matters. I know if people can get out through a kernel bug, that's definitely terrifying. It's just a question of do they even need root to cause any damage at all? Do they even need to get out? I think that, it's deployment specific, but it's definitely a consideration, I think, when exploiting Linux these days, like how far do you need to go? And actually on one other part of that, it's interesting because we have honeypots that we have stood up, and we're trying to figure out, based on what we've seen from attackers that have landed in containers, most of the time they end up just running Bitcoin miners or other cryptocurrency miners. Was that their end goal, or was it that they saw they're in a container and figured that there was nothing better to do? They didn't have an escape or wasn't worth spending the escape, right? So trying to discern that based on observing attacker behavior is really interesting right now. We haven't seen anyone throw the Sudo exploit in the last 2 weeks in the honeypot. I don't think, at least. I'd be curious to see if someone even thinks that's worth it, because they're in a container. What does it matter if they get root in the container? They're still not getting out. So, or if they have a kernel bug, are they gonna throw it? So, interesting. It's an interesting thought exercise for sure.
Definitely. And go ahead, John.
On that, I was going to go in a different direction, but this one just popped in my head. So on that, in the honeypots, are you guys seeing people run commands to tell if they're in a container or not?
Once or twice we've seen people poke around for doing that. A lot of times they run a few initial recon commands that I don't know that if it's looking for a container, there should definitely be signs of it, right? The host name, PS should show a PID that, the PID 1 is not in it in any of these containers for us. We don't have a full, we don't have containers that are representative of a full lift and shift where the whole, you've got the whole userland suite of programs running with its own system and everything else in the container that I know a lot of people do run. So it might be interesting if we were to do that, would they poke around more to determine it's in a container? Because it should be pretty obvious when they first land. I would say the most interesting thing is that they do recon to see who else has landed in that box. And they try and kill other crypto miners that are running, for example. It's kind of funny.
Interesting. Huh. So where I was going to go with that, actually, my original point before that one kicked in, talking about these container things, and we're talking about root or not root, but also we've seen over the last 3-4 years the slimming down of these container images in particular, right? Alpine and things like that. Like, how light can you get that? A, to make the container lighter to move around, but also B, to sort of minimize the security footprint. So that should help, you would think. But then back to what you're saying, like, as we take that container, which we've now slimmed down and hardened, we're putting it into more and more complex environments where there's more and more bells and whistles to be adjusted or adjusted correctly. So you're sort of wondering, you've made this little thing secure, but now everything that's around it is sort of becoming, it might not be the Linux problem, but it's still, I've heard people refer to Kubernetes as the Linux of, container, like an operating system like thing. So is the ball just shifting? Do we care as much about securing Linux versus what we did 5-10 years ago?
I do think it is Kubernetes definitely represents a shift of attack surface towards this orchestration layer. I mean, just like any orchestration layer you would have in a network, right? It becomes a juicy target. This happens to be running your container instances. I do think Linux security is still a relevant element here, because the userland initial vectors that get you into the container are still the same sorts of problems, right? It's still command injection and memory corruption, and deserialization bugs, assuming you're exploiting instead of trying to like supply chain to get in. And I actually think the attack surface there has it's just exploded. You may have slimmed down the container so you don't have any of these other traditional Linux services. You're not doing the lift and shift. You've purpose-built your container and it has the minimal amount of things running inside of it. But it seems that the paradigm for programming anything these days is to import something that imports 6 more gigs of something else that then carries that chain of imports until it doesn't. And so, getting some sense of what attack surface is coming in there, I think becomes a harder problem when you've slimmed things down. But yeah, obviously I support attack surface reduction, right? That's always a goal. And I think containers definitely foster that sort of movement.
So kind of riffing on that and switching maybe a little bit into the defending aspect of the conversation too. John pointed out the idea of slimming down that Linux distro as much as possible. And Brandon, you had mentioned like BPF. One of my questions though is how much of, with something of BPF, I love the idea of it and think would be a great way to secure a system, secure a container, but it's also pretty complex as well, let alone the complexities we were describing as you two were just describing the broader aspects of Kubernetes. So my question sort of is then, how much do you see BPF being as much of a, call it a preventative or hardening step versus maybe just that monitoring step? So as much as we were talking about, maybe root doesn't matter as much. If I come and say, maybe hardening isn't as important as just knowing what's going on in the container, is that certain a mindset that's healthy to go down? How much weight should we put into something like that?
I think monitoring is probably the first thing that should give anyone any sense of security comfort, regardless of any other mechanism. I mean, we know as an industry that prevention is never 100% successful, and that there's so much dynamic movement happening at any given time. It's hard to have a grasp on how much prevention is actually in play. And then without monitoring, how can you be confident? How can you test that prevention is working? And so like BPF, BPF I think is great as an example of something that's monitoring, so long as it's not introducing, more attack surface. There have obviously been like BPF verifier bugs, or ways that people have demonstrated BPS for rootkit. So it's a double-edged sword, but I think having the monitoring is better than not, for any of that sort of environment. Especially when you're considering things like supply chain or, just confidence in that the build that you have is in fact what your build tools tell you that they are. If something's lying dormant, or even if there's a 0 day, or if there's a bug in your third-party applications that you're, the code that you're writing, not that the vendor has supplied and not that you've purchased elsewhere, but just from in-house, you can slim down as much as possible. And I always support that sort of effort, but without monitoring, I don't think you can have any sense of confidence in the behavior of your environment.
Yeah, I like to think of that as the sense of riffing on a common phrase. Attackers only need to get caught once if you have good monitoring, and that way it brings back some advantages to the defender. At least I would hope so, being able just to see this is an anomaly or this is something that clearly shouldn't be happening.
Yep, Yep, absolutely. And I think that's another beautiful thing about containers. They let you express intent in a way that you can get a better sense of what should and shouldn't be happening. And Linux as a server in general, right? Like end user, laptops, whatever operating system, doesn't matter. It's chaotic. But the more tightly defined the operation is of the thing that you want to keep secure, the easier it is to define parameters for what you should be monitoring or what doesn't look normal, at least what normal looks like. And then anything that falls outside of that is not. And I also think that people are, you bring up the attacker advantage defender's dilemma, and it's an interesting thing. I think the whole attacker only has to be right once. Defenders always have to be right, but I think there's a home turf advantage that defenders have with the ability to modify their environment, or have canaries, or set up things that are juicy that would create a loud signal otherwise, and then monitor for that inside their environment. And there's all sorts of stuff they can do to make it far more hostile for attackers, especially when you've got the dynamic rollout mechanisms that you have with container management. So I'm hoping that this becomes an opportunity for people to realize that they can shift that a little bit in their favor and get some asymmetry for both preventing and detecting attacks.
So let me also ask a question to broaden slightly just outside of containers, just containers, but still talk about reducing attack surface, protecting the system. We talk about BPF, okay, great for possibly just monitoring more so than hardening. But what about, there's ASLR, there's kernel ASLR, there's static linking. How do these play into that strategy that you were focusing on about just making that home turf just less advantageous or less useful to the attacker?
Yeah, so that triggers me a bit. So I think, I'm a huge fan of these memory protection mechanisms. I think that they've raised the bar, and in many cases they've eliminated bug classes entirely. But I think like KASLR, like kernel ASLR, has proven to be more of a pain point for most to not be fully effective. And since it's not fully effective, you really are going through all this pain to not actually achieve the end goal. And I think Spender had actually tweeted about that and has some thoughts, and I could probably speak to that. But it's something with which I agree. So I think there's always a trade-off to be made between, how much hardening you're putting into the host versus what you're actually doing in practice. And you certainly shouldn't be going down a path that's going to disable your ability to secure the system or have observability into the correct operation of the system, right? So, when you get into Linux, like integrity and confidentiality lockdown modes, if you are locking down a box, quote unquote, locking down such that you can no longer observe the behavior, you're now, is that really giving you a benefit? Like, how can you be sure that it is always correct if, the attacker doesn't have something that you couldn't anticipate, but that you maybe would have been able to see if you didn't have such restriction on your own observability mechanisms? So, that is, I think, an interesting problem we face, and it's the decisions that get made there seem to be arbitrary or based on stakeholders in somewhere in the development path. And I think as a community, we'd be better coming together to talk about the pros and cons of different hardening or monitoring approaches to say what is worth trading off versus not. And I think this is the reason why you haven't seen the full lockdown mode shipped with any major distro, because it doesn't make sense, both from a debugging, just ops stability standpoint, as well as from a security monitoring standpoint.
Yeah, that final part. Go ahead, John.
We're sort of leaning towards something interesting here. Not as interesting as I'm sure what you're about to ask, Mike, but last few years when I've been able to interact with customers of various companies, the large orgs that have really, really sharp, really good security teams, those guys, they're quite familiar with most of these, very particular, very finicky controls to give you some of these home field advantages, like the kernel ASLR and things like that. But where does that leave the rest, the folks that that don't have that hardcore security team that Linux is running in our environment? How do they? And I'm sort of setting you guys up for a pitch here a little bit, but what's your thoughts, either company wise or not? How does the guy who's got 3 people and wants to run, I don't know, it doesn't matter the actual end technology, but something on a Linux type system, whether that's your phone or a cloud, how do they get some sort of advantage here, or are they just left sitting?
I think that's a great question, and one that should be in consideration for how these sort of mechanisms are deployed. Because if it's only the top 1%, if it's only the people with dedicated teams, you think about the water treatment plant with TeamViewer getting compromised. It's like that was obviously deployed as a matter of convenience and management for the one IT person that's probably also security. So does that person have the time to spend enabling selective kernel patches in their configs and then doing test rollouts and hoping that they've instrumented everything properly? I don't think so. So it definitely opens the door for I think us, but really any monitoring. Like you need to be able to provide something for people to just have some sense of comfort in what's running without needing to have an elite team of kernel developers to deploy it.
Yeah.
So yeah.
And that's a great point. I'm kind of curious too. Then, are there other ways that you can suggest or think that either the distros themselves or maybe the security industry or tooling industry can help here? Because, for example, you had alluded to, what if we just got rid of Sudo or just rethought that idea of password-based authentication and did something with, I think you were getting to like SSH keys or certificate-based. Is that a path that's going to be able to go down that's viable for Linux users in general, or are we still stuck in the great, you've got an elite security team with a massive budget who can deal with this, and everybody else is this long tail that's still going to have to struggle, though?
I think we would do ourselves a bunch of benefit if we were to reevaluate the sort of givens that we've been living with versus what we could be doing. I think it's something that's always wise to do in technology, especially at the rate at which we adopt new attack surface. Rather, we take it on before we even fully comprehend what we've already accepted as risk. And so doing that and then taking the acceptable terms now in 5 years might not be acceptable as far as how you should be addressing the problem. I do think Sudo is kind of a maybe it's a necessary evil now because we won't ever be able to get rid of it. But I think I personally would rather limit root to only being able to authenticate as root with a key somehow. Though I don't know actually what that would look like in practice. Your question is a very good one, because what does that look like in practice now that we've become so used to this modern change? Yeah, I think I wanted to explore this and actually some other topics around how people are looking at targeting those sorts of elements for exploitation across all of the distros and where the hardening lies, which I think we'll actually be talking about more on the next webcast coming up on is that the 18th? And discussing like what are the differences that between distros, between environments that lead attackers to want to explore more, like how they should target something versus what distros should be doing to make it easier and harder for them to compromise. Everything from like package hardening and ASLR to like where do we see like an adoption of, for example, Go binaries, but that are using CGO to import libraries, where it's like the Go binary is presumably safer because it's statically typed and you have much lower likelihood of memory corruption. But because of that, most of them are compiled without ASLR. So now if they're importing a C library that could introduce attack surface, are you worse off than you were before? And trying to look at like the trends as we move towards that, as we take on new technologies and new approaches to security, where do we need to reconsider, like, okay, at this point it was acceptable to take this approach, like not having ASLR in a Go binary, but maybe that changes now that we're importing C libraries or migrating in that direction. So I think it's always important to reassess what you're doing and what is possible and what would actually engender the best outcome.
It's a great point. I'm going to bring us a slight curveball here in that concept of trends and where we're going. And, there's cloud, but there's also serverless. So the cloud already has abstracted Linux to a degree that hopefully you don't realize that it's just the case that you don't realize you're not running Linux or that you are running Linux. But serverless is even more of an abstraction in the sense of you're not even in control necessarily of the distro itself or what hardening is available to you. So in that realm, do you see something meaningfully changing here in the sense of what you were just describing with attacking, targeting, or even defending Linux from this perspective of ASLR to supply chain to what privileges you're running at? I'm just kind of curious how much of that might change this thinking.
Absolutely. So, it definitely changes your requirements for monitoring and the sort of things you're going to want to concern your environment with as far as observability goes. You're now not in control of the kernel or the kernel patches, and you're putting faith in the provider of that, or really most of the environment, right? If you're running serverless, it's just your code that's running, but you still need to have. I think that actually further underscores if the requirement to have monitoring capabilities from within your application, perhaps. But it definitely changes. It definitely changes the requirements because you have. You can't deploy VPF, for example, in those environments to observe stuff because you don't have access to those facilities. So your monitoring requirements definitely change. Your deployment requirements definitely change. And I think you would need to have some way of getting assurance that your Lambda instances are not, or whatever they are, serverless instances rather, are not compromised and behaving poorly, especially given that people are using a lot of serverless stuff as like glue to transmit between or to do some lightweight processing between other elements in their frameworks and their platforms. And when you're sitting in that sort of position, it's definitely a huge point of vulnerability, as it's often in a privileged position connecting two things that are doing something sensitive. So I definitely think it changes your monitoring requirements. And as we move towards that, I think we're going to see more attacks against that are going to be eye-opening. They're going to raise questions around our expectations and assumptions that have changed.
Definitely. So, kind of looking forward, you were, talking a little bit about what can we do as an industry to rethink perhaps authentication? What would that look like? Do you have, and I'm putting you on the spot here a little bit, do you have sort of a wish list, one or two things that you would love to see different in either Linux kernel, in distros, or just something about that Linux ecosystem? So, let's say if we roll forward a year from now.
In a year, that's a good question.
Or maybe a year isn't long enough.
Yeah, I mean, it doesn't. They manage to change so much, and yet certain things take forever. It's true of any software. But I think the ability to tune exposure of data collection, more of it for security purposes, but through general purpose stuff. So not just like SE Linux or the other LSMs. It would be nice if we saw that consideration, so that things like different lockdown modes could still have some amount of data collection if people wanted to turn that on. And then I think, I don't know, it's a really good question. Attacks, I really don't know what I would need to think longer about that for what would make a better thing to be baked into the kernel. There are many things, and they are actually doing, I think, a great job baking stuff into the very modern kernel. So maybe in a year, the things I'm thinking about now wouldn't even be as necessary.
No, that's interesting. I think, one of the themes that you've given us today is observability is pretty critical, regardless of distro, regardless of how or where the Linux is deployed. So, just for that observation alone on observability, we thank you for talking with us about that.
Yeah, and thank you for having me today. I would definitely say observability is a theme, especially because without it, you can't make any assertion of anything else in your environment or your security posture. And you certainly aren't going to catch something like a supply chain attack or even just an unwanted dependency that slips in and is of perfectly fine version, but if it misbehaves in some way, how would you know? So I think I think observability is just so crucial, and something that we just haven't had with Linux because, like I said, it transitioned from being the hobbyist operating system to suddenly running all of production. So it's like we looked back and we're like, oh wow, look at that. We can't really see into any of this. So it's I think a huge stepping stone, the most important place to start for getting a better sense of security on Linux.
No, and this was a great important place to start for us for this conversation. And I'll remind everyone that there's, you alluded to this, there's a webcast coming up on March 18th titled Preparing Linux Hosts for Unexpected Threats. So we would hope everyone would come visit securityweekly.com/registration to sign up for that and hear more about this particular topic from Brandon and his cohorts. So just with that, want to send you there, check out the registration, say once again, thank you, Brandon, as well as speaking about observability and thinking of things as they're misbehaving or not. Thank John for joining us as well. We are going to take a quick break and return with news of the week.